I hope the previous video was useful and informative. Let's move on to the next part. First question. 500 gram of water is heated from 30 degrees Celsius to 60 degrees Celsius. The change in internal energy of the water after ignoring the slight expansion of water is dash. Given that the specific heat capacity of water is 4184 joule per kilogram per Kelvin. The reason I am referencing school textbook is that you need to master them before moving on to the standard degree level books. Given data m equal to 500 gram, which is equal to 0.5 kilogram, temperature T1 equal to 30 degrees Celsius, which is equal to 303 Kelvin, T2 equal to 60 degrees Celsius, which is equal to 333 Kelvin, C equal to 4184 joule per kilogram per Kelvin. You have to find the change in internal energy delta U. We know specific heat capacity Q equal to mCT. In the question, ignoring the slight expansion of water is given. Hence, Q equal to delta U. Hence, change in internal energy equal to mc into delta T, that is the change in temperature. Substitute the given values and solve. Finally, we get delta U equal to 62.76 kilojoule. The answer is option C. Second question. Nitrogen gas is compressed adiabatically from a pressure of 1 atmosphere to a pressure of 2 atmosphere. The fractional change in the RMS velocity of nitrogen molecule is dash. Given the ratio of specific heat capacity gamma equal to 1.4. The given data, pressure P1 equal to 1 atmosphere, P2 equal to 2 atmosphere, gamma equal to 1.4. We have to find the fractional change in RMS velocity. From the root mean square speed formula, Vrms equal to square root of 3 RT divided by m, which we can write it as Vrms is proportional to T to the power half. The adiabatic process formula, T to the power gamma into P to the power gamma minus 1 equal to constant. This can be written as T is proportional to P to the power gamma minus 1 divided by gamma. By comparing equation 1 and 2, we get Vrms is proportional to P to the power gamma minus 1 divided by 2 gamma. Let's find the power term gamma minus 1 divided by 2 gamma, which is equal to 1.4 minus 1 divided by 2 into 1.4, which is equal to 0.4 divided by 2.8, which is equal to 1 divided by 7. When the pressure is at 1 atmosphere, V1 equal to P1 to the whole power 1 by 7, which is equal to 1 to the whole power 1 by 7, which is equal to 1. When pressure P2 equal to 2 atmosphere, V2 equal to 2 to the power 1 by 7, which is approximately equal to 1.1. The fractional change in the RMS velocity equal to delta V RMS divided by V1, which is equal to V2 minus V1 divided by V1. Substitute the values, we get 1.1 minus 1 divided by 1 equal to 0.1. This can be written in fractional form as 1 divided by 10. Make it sure by thoroughing the formula, then only you can solve the problem within the given time. The answer is option D. Third question. Calculate the efficiency of an auto engine having adiabatic compression ratio ρ equal to 9. Given ratio of specific heat capacities equal to 1.5. You can find the efficiency of auto engine formula in the Heat and Thermodynamics by Bridgelal and Subramaniam book. Let's write the given data. Rho equal to 9, gamma equal to 1.5. We have to find the efficiency eta. Eta equal to 1 minus 1 divided by rho to the power gamma minus 1. Substitute the values, we get 1 minus 1 divided by 9 to the power 1.5 minus 1, which is 0.5, that we can write it as 1 by 2. 9 to the power 1 by 2, which is root 9. Hence, eta equal to 1 minus 1 divided by root 9, which is 3. Hence, eta equal to 1 minus 1 by 3, which is equal to 2 by 3, which is equal to 0.666. In the percentage form, the answer is 67%. The answer is option C. Fourth question. What does happen when a rubber band is quickly stretched? The answer is option A. It warms up. Fifth question. Degree of freedom of mosquito flying in air is dash. The answer is option A 3. Sixth question. Match the following. First one, monoatomic gas is helium. Second one, diatomic gas is carbon monoxide. Third one, triatomic gas is sulfur dioxide. Fourth one, ideal gas, which is the real gas at low pressure. Hence, the answer is option A. Seventh question. Calculate the power radiated from a 1 millimeter squared surface at a temperature of 3000 degrees Celsius. First write the given data. A equal to 1 millimeter squared, which is equal to 1 into 10 to the power minus 3 the whole squared meter squared. Temperature T equal to 3000 degrees Celsius, which is equal to 3000 plus 273 3273 Kelvin. We have to find the power radiated. According to Stephen Boltzmann law, the energy radiated per second per unit area is equal to sigma T to the power 4, where sigma is the Stephen Boltzmann constant and its value is 5.67 into 10 to the power minus 8. We can write the energy in terms of power as power equal to energy divided by time. Hence, P equal to sigma A into T to the power 4. Substitute the values. 5.67 into 10 to the power 8 into 10 to the power minus 6 is area, that is surface area, and the temperature can be written as 3.273 into 10 to the power 3. Separately, I have applied the power 4. We get 5.67 into 3.273 the whole power 4. By simplifying the powers of 10, we get 10 to the power minus 2 only. Multiplying the two terms, we get the answer as 650.68 into 10 to the power minus 2. Hence, the power radiated P equal to 6.5 watt. The answer is option B. Eighth question. The heat capacity is negligible for all diatomic molecules only is below dash. The answer is option D. 2000 Kelvin. Ninth question. The Clapeyron-Clausius equation is associated with dash. The answer is option D. Both enthalpy of vaporization and enthalpy of sublimation. 10th question. The voltage temperature graph represents isobaric process at two different pressure. P1 has larger slope than P2 because the answer is option D. V equal to mu R divided by P into T. 11th question. If the frequency of the magnetic field applied between the Ds of a cyclotron to accelerate a proton is 53.4 MHz, then the value of applied magnetic field is dash. The given data, frequency f equal to 53.4 MHz, which is equal to 53.4 into 10 to the power 6 Hz. We have to find the magnetic field. The frequency f equal to bq divided by 2 pi m. From that, the magnetic field B equal to 2 pi m into f divided by q, where m is the mass of the proton and its value is mp equal to 1.672 into 10 to the power minus 27 kilogram, and q is the charge of the proton, which is equal to 1.6 into 10 to the power minus 19 coulomb. Let's substitute the values. 2 into 3.14 into 1.672 into 10 to the power minus 27 into 53.4 into 10 to the power 6 divided by 1.6 into 10 to the power minus 19. By simplifying, we get 350 into 10 to the power minus 2. hence B equal to 3.5 Weber per meter squared. The answer is option B. 12th question. Number of neutrons generated by a single neutron in uranium-235 during nuclear fission is dash. The answer is option A 3. 13th question. If the Bohr's radius of the hydrogen atom is 0.529 angstrom, then the radius of third orbit is dash. According to Bohr atom model, the radius of the nth orbit of hydrogen atom or n equal to a0 into n squared. The given data, a0 equal to 0.529 angstrom, n equal to 3. We have to find the radius of the third orbit R3. Solution. The formula is Rn equal to a0 into n squared. Substitute the values. We get R3 equal to 0.529 into 3 squared, which is equal to 0.529 into 9. Hence R3 equal to 4.761 angstrom. Hence the answer is option A. 14th question. The difference between shortest wavelength of Balmer and Lyman series is dash. The wave number of Lyman series is nu bar equal to 1 by lambda equal to R into 1 divided by 1 squared minus 1 divided by m squared. And for Balmer series, nu bar equal to 1 divided by lambda equal to R into 1 divided by 2 squared minus 1 divided by m squared. We have to find the difference between shortest wavelength. For shortest wavelength, m equal to infinity. Hence, for Lyman series, 1 divided by lambda equal to r into 1 minus 0, because 1 by infinity is 0, which is equal to r. Hence, lambda L equal to 1 divided by r. Similarly, for Balmer series, 1 divided by lambda B equal to r into 1 divided by 4 minus 0. Hence, lambda B equal to 4 divided by r. The difference between Balmer and Lyman series, delta lambda equal to lambda B minus lambda L equal to 4 divided by r minus 1 divided by r, which is equal to 3 divided by r. Hence, the answer is option B. 15th question. If A be the mass number, m be the atomic mass, then packing fraction F of the nucleus is dash. The answer is option C. F equal to m minus A divided by A. 16th question. Which of the following numbers are not representing the magic numbers? Magic numbers are the definite number of either protons or neutrons of a stable nucleus. It is the evidence for shell model. The magic numbers are 2, 8, 20, 28, 50, 82, 126. Hence, the answer is option D. 17th question. Zeeman effect is which of the following phenomena? The answer is option A. Magneto-optical phenomena. 18th question. According to Bohr atom model, the energy level of an atom with atomic number Z can be obtained by the formula. The answer is option C. En equal to minus 13.6 divided by n squared into Z squared electron volt. 19th question. The space quantization and spinning of electron can be explained by dash atom model. The answer is option C. Vector atom model. 20th question. Which one of the following is explained using Sten and Gerlach experiments? Hence, the answer is Option A and C, existence of electron spin and existence of spatial quantization. Thank you.